Welcome to the webinar of the mioty Alliance. It's the first one in this forum that we do. My name is Micha Burger. I'm a solution engineer here at the mioty Alliance. And the goal of today is to give you an overview of the mioty ecosystem. It's a bit the bigger overview. There has been a lot happening lately, so we're happy to show you a bit around. Today with me, there is Peter Hedberg. He is the general manager of the mioty Alliance, and he will start with a quick overview of the mioty technology and show some real use cases that we have at the moment. And next we will have Manuel Hart speaking. He's the managing director of Sentinum, who is a mioty Alliance member, and he will show you about the ecosystem, devices that currently exist, and basically everything you need to draft the complete mioty system. So this overview that we have will take us around 30 to 35 minutes in this webinar. And then there will be 10 more minutes for questions for you to ask in the end. And so we will be done by 11:45. So you can have your lunch break wherever you are on the world. Just some housekeeping. So this webinar is being recorded. Just make sure you're okay with that, or otherwise turn off your camera and whatever. And please turn off your microphone. There will be the possibility to speak if you have questions at the end. So if you already have questions now, you can always add them to the frequently asked questions. There is a part here in the Microsoft Teams infrastructure, and we will try to answer them already as we go. Or also at the end, you can ask your questions and then we will make a turn. Great, thanks a lot. So we will get started with Peter.
Thank you, Mika. So welcome to you all. And as Mika said, we'll give you a brief overview here of the mioty technology, but focus on the ecosystem. Let me just share a few slides here with you guys and girls, and to show you what first of all, what the mioty Alliance is. So this is my role as general manager is to lead this alliance, and it's a community of people, businesses, institutes that share this vision to make mioty a global standard, basically, and really make sure that we have something that is robust and efficient on the market. It's the Alliance today is around 60 organizations, a mix of companies and universities, and we also have a number of partnerships to promote and make sure that as many as possible get their eyes on and start using mioty. But today it's more about the technology as such and ecosystem, and just to give you a very brief introduction to what mioty is. I guess many of you know a lot about it, but still just to keep everyone on the same page here. So the technology was invented by the Fraunhofer IIS, which is part of the big Fraunhofer organization, one of the largest research institutes in the world. And as you see down there at the bottom, Fraunhofer IIS, they have some other pretty cool inventions under the belt, so to say, with MP3 and DAB+ and so on. That said, mioty is really a state-of-the-art LPWAN technology, and I'm really proud to lead the Alliance and also to be able to work with this amazing technology on a daily basis. So what is it then? Well, low power wide area networks. So what we see here is a screenshot or a screen dump from the spectrum. It's the European spectrum. You see down there on the x-axis, 868 megahertz, which is where we reside on these open bands. And this shows what it looks like when you do a 10 bytes transmission. This is a typical LPWAN application that could be transmitting some meter data, temperature, a GPS position, or whatever it might be. As you see here, so the time axis on Y and the frequency axis X, these technologies, even though they do the same thing, it looks quite different on the spectrum. And you might argue, why is this important? Well, in a clean spectrum, it isn't really important because then everything works. But since it's open, these bands are open, there's lots of noise. So you have lots of other things communicating on these bands as well. And as you have noise, well, if your message, when you transmit, if it's quite spacious, both in frequency and time, you run a much higher risk of actually colliding with something. With mioty, these little dots, we can sort of sneak in between in many cases. The principle is like this. So let's call it legacy LPWANs because they're actually older than the mioty technology. So LoRa and Sigfox and others, they take the data, ABCD, and they put it into one message, one packet, and then you transmit. If there's interference, you will lose data, or you lose the whole message. With mioty, we do it with the patented telegram splitting technology. So we take the same data, ABCD, split it into sub-packets, and there's some redundancy in these sub-packets, transmit with frequency and time shift, and yes, we will also be hitting some interference, and some of these sub-packs will be lost. But if 50% or more of them survive the journey, we will recompose the message in full. And this is really where mioty differs from the other technologies. I will just give you a few simple examples here of how this is visible in real life situations. So a first case is just a test that was done in Prague, where the customer wanted to compare the radio reception performance, mioty and LoRaWAN. And this was done in Prague. And they just set up a very simple, you see the picture to the right there, a very simple antenna site with a combined mioty and LoRa gateway. And they took 5 water meters and fitted them with mioty and 5 with LoRaWAN. And then they put these 2 water meters in typical installations in Prague. You see these small pictures here to the left. So in pit holes, basically. So you put them down there, half a meter underground, then you put a lid on top. It's quite tough to get a signal out. And the one closest to the antenna site was 208 meters, and the one furthest away was 2,000 meters away. And the result was quite compelling. If it had been a clear line of sight installation, both technologies would have worked nicely. But here you have a very, very tough radio situation, and mioty is quite superior in these types of situations. Another and one of the members of the alliance, Swissphone, they are actually, this is what they're really pushing out there to the market, the robustness. In critical infrastructure, you really need to be able to rely on the technology so that you get the messages through. And this is a case that is being rolled out as I speak here in Südtirol, where the local authorities, they've decided to set up a critical infrastructure network covering 7,400 square kilometers to allow the population to have alarm buttons if something happens, so they can press these buttons. The signal must come through because it could be a life-saving situation. So here is a very clear use case of the robustness of mioty. Another very important part in IoT is the scaling factor. And here's a case from Dielmetring, a city of Erfurt, where the customer, they wanted to do LoRa first because they have a LoRa network, but they wanted to compare with mioty as well. And the first phase of the project was 30,000 water meters. And they needed 40 antenna sites to cover with LoRa. It was enough with 17 with mioty. The second phase was an additional 60,000 sensors, and then they needed another 23 antennas with LoRa, whereas it was still enough with 17 with mioty. And this is really money in the bank. Every site costs, so you can save a lot of money. If you have big installations, you can save a lot of money with mioty. There are a number of other benefits. You see them listed here. I will not go through them here today because, as I said, today is focusing on the ecosystem around mioty. So with that, I leave it to my colleague. Manu.
Yeah, thank you, Peter. So let me introduce quickly myself. My name is Manuel, and I'm one of the founders and managing directors of Sentinum. Yeah, we are in charge of developing end nodes and sensors for different applications with mioty. And I'm gonna introduce you now the mioty ecosystem. So basically, I think you all know what we're speaking about. Just for those who are new to the topic, how does mioty work? Basically, from the network topology, it's a star. So you have different kind of sensors. That can be battery-powered sensors, that can be meters, that can be temperature sensors, water meters, electricity meters, environmental sensors that report all the data to a gateway or to multiple gateways. And from the gateway, the data is processed, comes more or less to a cloud backend or cloud or application cloud. And from that, you can monitor the data in any tool you like or any provider you have, and you gain some value out of the data. So for the ranges, mioty works like, I mean, it's difficult to say because if you're underground and have like a lot of walls and steel between the sensor and the gateway, it's difficult to tell. But I would say like 1 to 15 kilometers is something you can achieve if you have line of sight, if you see the antenna. Also more than like 500-600 kilometers are possible. So if we go to mioty, we can see that we have like, yeah, different meters or different sensors on the left side. We have like a very good penetration and scalability with mioty, as Peter showed before on his slides. And from multiple endpoints, we have a so-called, it's not called network server. This is like a different point we have with mioty. It's a service center and application center. They're often merged together. Nevertheless, you can also separate them. I will show you the difference between Service Center and Application Center on the next slides. And from that, you can go to like IoT data platform and yeah, do your business intelligence, process the data, and gain some value out of the data. So if we separate this a little bit, you have like different layers. So the endpoints are here on the left side. The base stations are like coming next to the endpoints. And the base stations basically communicate via a standardized protocol. It's called BSSCI. This is the protocol where you can connect the base stations to a service center. From there, it's also a standardized protocol, SCA-CI, for connection between service center and application center. And from the application center, for example, you can go with like MQTT and REST to different IoT platforms. Yeah, what you prefer, you can go for ThinkSport, Grafana, and some other platform providers. However, there is, of course, another solution. So a lot of gateways support it, that you can put the service center and application center SCAC on the gateway directly. So that means you can have a secure connection from the sensors to the gateways, like where the service center and application centers are managed, directly to like an IoT platform. This is basically how the mioty architecture works. If we go one step deeper, because like this might be a little bit more technical for you, but I think it's mandatory and like interesting because it's different to some other technologies, that we separate the service center application center. So what are the tasks basically for the service center? The service center basically defines the network, gives you security on network level, and sorts out or multiple messages that are going to received by multiple gateways. And it's also responsible for the downlink tracking through different classes. So also with mioty, we have different classes, ABC, as you might know, like from other technologies. As I told you, the communication is standardized through BSSCI from this service center to the application center. The application center is more or less the point of contact, or the the managing tool that interacts with the end user. So if you want to put some new sensors in, like the credentials, DFIOE, short address, keys of the sensor, you more or less use the application center. And in the application center as well, you can do the payload decoding. For the payload decoding, we also have a standard. It's called blueprints. So you can just like put JSON blueprints in. That's more or less defining how the payload is decoded into human readable language. And from that, for example, you can transmit the human readable JSON files to your IoT platform and end customer platform. The application center has also like a different, like it can be a different architecture. So in a lot of cases, the service center and application center are merged together that can run, as I told you, on the gateway or on like a different server in the backend. But you can also have the application center being established in like or as part of an IoT platform. These are the two options that are, or three options, let's say, that we can see in the field from our customers in big scale networks. So the mioty ecosystem components and suppliers, as Peter mentioned, like we have like a lot of members and are rapidly growing. So if we start from endpoints, we have different vendors and manufacturers for endpoints. For example, you have WICA pressure sensors and WICA 4 to 20 milliamp to mioty bridges. For example, Lansen is on board with a lot of products for building intelligence and building management. We have Aquolution for environmental measurements and smart agriculture. We have Miromiko with like a lot of different sensors. We have Vidra, of course, Sentinum. We have Comtac with different sensors. We have EBZ for electronical energy meters. We also have WebTech and much more companies where you can find on the homepage or in the mioty store. I will tell you that later as well. We also have like much more. We have like Swiss Phone, of course, Steel, and there are much more hardware and endpoints upcoming. For the base stations, we also have different vendors. For example, ASTX, they have like an indoor and the new IP69K gateway. Also RAG offers gateway for mioty. We have Vidra base stations. Also hybrid base stations are possible that do mioty and other protocols as well. We have like the deal metering base stations for Miromiko, indoor and outdoor, Swiss Phone base station, also like more industrial direction from IFM. Something will coming soon. We have also like other vendors like WebTech, more like a Raspberry Pi base station. We have Greytech with a series of endpoints and base stations as well. And I'm sure you can find also different vendors for base stations nowadays. For the service center, application center, which we talked on the previous slides, what is commercially recommended is Loriot. They offer like different plans for mioty service center, application center, or network server management. They also have like hybrid solutions if you have other existing protocols running. We have also like open source network servers, which you can find on GitHub. So feel free to join and to work on that, to test it, to try it out. And we also have a integration, for example, for smart home assistant. And also on this side, there are some other proprietary things big companies are using, but there is more things upcoming next year, so that we will have a broader range on this topic. For the IoT and platform providers, for example, we have Akensa on board. They are offering like, let's say, a multi-purpose IoT platform. We have like, for example, Spectre with a focus on heavy rain, risk management and flood prevention. We have from Aquolution the Farmalizer that is more for agriculture business. We have the building monitor from Tesla. We have the deal metering portal as well. And of course, you can use, for example, ThinkSport, Grafana, or connect basically mioty networks to the platform you use. That could also be data cake or some proprietary SCADA systems and industrial things, or some other systems that you can connect the mioty networks with standardized interfaces. So if you say, hey, I want to go the next step and see, hey, what kind of sensors do you have, where to find them, one option is the Mioty Alliance homepage. It's like, very, you can filter between gateways and devices, and there are like we really like try to get all devices there. There are all devices from the different vendors that you can find. Also, for example, wireless MPOS Mioty bridges and so on from different vendors. So yeah, feel free to have a look there and see how the devices can help you if something is missing. Of course, feel free to write a mail and say, hey, I'm covering this use case. For the use cases, for the standard IoT use cases I think we are covering 95%. There are some white spots at the moment, but like most of the IoT use case, we are covering with the sensors you can see on the Mioty Alliance homepage. We also have a Mioty store where you can buy those things. This is just like an excerpt of like different things we offer there. So the Mioty store in general offers hardware, endpoints, gateways. We have some news on it, and we'll also covering bigger projects in the future, done with customers with the sensors and gateways that you can find on the Mioty store. We have like let's say the most important vendors there, and like we are improving and extending the portfolio from time to time, or yeah, we try to do it like rapidly to have like a big choice from different sensors. We covering at the moment, for example, Vitra, Vika, Lansen, RAG, and a lot of gateways manufacturers. So also feel free to check it out there. If you can need something, you can order it, and we are happy to ship it. Of course, you can also go to the manufacturers directly if you have like in-depth questions or special needs for some applications. Another thing, Mioty regarding other technologies and standards. So what for me, or like for the whole alliance, for our customer, a big advantage is that Mioty is fully standardized in ETSI. So it's a real standard that more or less is software defined and like vendor free. So with Mioty, if you like want to make a Mioty sensor or you buy Mioty sensor, you're not bound to one hardware manufacturer basically. So you can use like any RF chipset and just like make Mioty with it, or enable Mioty over like every chipset, RF chipset you can find. And yeah, we're like it's guaranteed, as it's like a ETSI standard. It's guaranteed that it's like a real standard for the IoT market. We are also reaching out to other standards. IO-Link, for example, IO-Link is like an industrial standards for connecting sensors and actuators of machines, or SPS controls or other controls. And this is like going like in a very, very good direction. I think like contracts are signed. I'm not 100% involved, but basically you can like have a Mioty IO-Link bridge, which I will show you on some slides later, where you can just connect every IO-Link sensor and basically transmit the data, the IO-Link data through Mioty. The same is for OMS. We have the initiative Mioty for OMS. That means that we can, or it enables more or less the interoperability between OMS and Mioty. So if you know wireless MPOS, for example, you can also do like OMS standard over Mioty, which is also a great achievement for the metering and building management sector. Maybe some use cases we have in the ecosystem. So, for example, for utilities and smart metering, there are a lot of products. We have, for example, Deal offering ultrasonic and ultrasound water meters. We have different clip-on modules for water meters. We also have temperature meters and like other meter modules where you can equip existing meters and sensors and transmit the data over mioty. This is also something we are like establishing more in the future to have like much more products there to integrate mioty on existing solutions or on existing meters. For example, if we go to building and facility management, we have leakage monitoring with a Lansen water leakage kit. So we are also offering different solutions there, rolled out solutions that are working in the field at the moment for like several years. For example, in this one, you can more or less like check if you have like a leakage in your building or on an industrial shop floor, and see that, give an alarm, and monitor it basically. Of course, from Lansen offers a much wider range of different sensors for building management that you can take a look at it. That are very, very widespread and used in the mioty environment and ecosystem. The next thing is more the industrial and logistics part for predictive maintenance and quality. So, for example, we have the weaker sensors, as I told you before, like we have pressure sensors, we have like an analog to mioty adapter 4 to 20 milliamps, which are battery powered. And we also like have from Sentinum the ION, it's called ION IO-Link to mioty adapter, where you can connect different IO-Link sensors. So why is this really important? So if you think about like wiring or cable laying in industrial manner, then we have like 20 to 50 euros per meter what it costs to lay cable, also communication cable. And this is the point. So with a mioty IO-Link adapter, from the one side, you can connect like any IO-Link sensor. And from the other side, you just connect power. Of course, there will be some solutions for energy harvesting and energy autonomous power supply, but at the moment we offered like a power cable. But what you get rid of is basically the communication cable, and this is what like a lot of, or what we could see in a lot of use cases and applications in the industrial thing. And if you think about it, that we have like between 20 and 50 euros per meter of cable laying. Then the question was, wouldn't it be useful if we could connect like all sensors in a production environment or like in a manufacturing or shop floor using a long range wireless standard. So you can like have like very, very limited gateways, and you like can connect different sensors at different points, also for retrofitting, and of course on the whole like production ground. So also outside like tanks, fill level measurement in tanks, like going to the basement, measuring different things like energy consumption or water flows and something like this. We can all achieve this with this mioty IO-Link adapter or mioty IO-Link bridge. What does the ecosystem look around it? So basically what you can do is you have like a really broad range of sensors that you can take basically. So you can take like, for example, IO-Link vibration sensors, IO-Link temperature humidity sensors, fill level sensors with ultrasound, fill level sensors with radar, pressure sensors, flow meters, and basically what the IO-Link ecosystem and sensors offer. I think it's up to 20,000 devices, something like this. You can choose between different vendors, just connect it to the adapter, and then transmit the data wirelessly to a gateway. And from the gateway, you can go to an on-premise or cloud solution. Of course, you can also like connect other sensors like directly, so without the adapter in between. You can connect, for example, a electricity meter. You can connect, for example, a CO2 sensor. You can connect another fill level sensor that like has a mioty on board. So without like having a I/O link sensor and the adapter in place, and transmit the data wirelessly to the gateway. And from the gateway, it comes through like Service and Application Center to the cloud. And why is this so important? So basically, this offers like with this product, we more or less like enable thousands more of sensors being used with a wireless protocol and with mioty. And it offers also like a very it enables other like fields of sensing or of measuring things in smart city applications. For example, I talked to some people that more or less working in the smart city sector, and they also told me this is like really great. We can really think about like new use cases in completely different sectors, as we have the accessibility of industrial grade sensors and just need the adapter to connect it, send the data. And so like I think this really can offer like a broader range of more and more applications also for other fields that are not in the industrial sector, but also like smart city and smart building. And this is a great initiative where we enable really a lot of sensors being wirelessly read out and transmitted the data. So thank you very much. That was it from my side, like a quick overview of the mioty ecosystem. If you have any further questions, you can contact me via mail or ask now, or just leave me a message. And yeah, I hope it was interesting for you. Thank you.